Login accepted.
That sounded pretty cool. I think that means we're supposed to get started. So let's do that. It's 1:30. That, by the way, is a picture of my grandson. His name is Alex. He was born 9 weeks ago, and he's super cute. You needed to know that. This is the title slide of the presentation that you're here to see. Hi, my name is Tim Berglund, and it is good to be back. Thanks for being here in person. I am so happy to be here in person. I think this is my third time here at Devoxx Poland, and I hope there's a fourth and a fifth and lots more, because this is a great place to be. I work for a company called Confluent, and I work with Apache Kafka a lot. I run the developer advocacy team there at Confluent, so our job is to make it easy and fun to learn how to use Kafka and learn how to build systems with it. And that's kind of what we're going to talk about today. Kafka is, this is not a Kafka talk, really, but it's really a talk about the kinds of software architectures that have tended to emerge around event-driven systems, what we'll broadly call event-driven architecture. I think there's a building consensus that event-driven architecture is a good idea, right? People are seeing, okay, there are benefits here, and those benefits are more valuable than the costs, the things that you're trading off. So it's a thing that more and more people seem to be excited about. But most of us are new at it. Sometimes I get to meet in person with people who are trying to build systems that are purely event-driven systems, and everybody's kind of building their first one. Right? Like, you know how to build monoliths. Everybody's good at that. But you break the monolith into pieces, and you want them to be asynchronous and reactive and all those cool things. And everyone's kind of doing their first. And it's hard. But they're not so new that we haven't been able to learn some lessons. So this talk is about some of those lessons, some of the things not to do when building an event-driven system. But before we get to the don'ts and the do's, I want to give you an idea of what I really mean by event-driven architecture. Now, I'm about to go through a diagram that I think I have presented in a different form, in a different, vaguely related talk on this exact stage. Now, the diagram looks different enough. It's been completely remushed and reformed. It's not. This talk has never happened before in public. But it's an idea and a kind of a reference architecture that I've been talking about for a while. And what I love about it is it's just so dang useful. There's a lot we can get out of this. So I'm going to show you. I've got this little reference e-commerce system, and I want to show you what I mean by event-driven architecture right here with this system. So here are some pieces. We'll start with these two things that have our web front end. Over there on the left, you've got a way of placing orders. There's some web front end, and maybe it's React, and it's going to create little blobs of JSON and impose them on that orders microservice over there. And that orders microservice has its own local database. It's not to be shared with anyone else. That's nice. Over on the right, you've got the same kind of thing for users. People can create accounts. They can edit their address and their name, and they can delete their account and go away and be forgotten, never to be remembered again. And that database is also local to that service. So there you go. Now, let's build out. This is not really quite a minimum viable product, so let's build out a minimum viable system with a few other services in an event-driven way. Now, when a user submits an order, says here, I would like to buy this thing, that order service will validate the order and write it to a Kafka topic. Now, like I said, this isn't really, and I'm saying Kafka just because I have Kafka on the brain. Doesn't have to be Kafka, okay? We're just talking about event-driven architectures in general. I will constantly go back to Kafka just because that's my habit. But this is a log, okay? That thing that I'm showing there in Kafka world, Kafka land, it's called a topic, but it's a durable log of events. It's not a queue. It's not something where we put a thing so that somebody can pick it up and then it goes away and it disappears after it's consumed. But it's a log that persists for potentially a long time. This is remembering the events that have happened in the system. That's very important. So we've got that durable log in between those two things. You put your order in that log, and the payments service says, oh, look, I have work to do. There's a new validated order in my validated orders log, so I'll pick that up and I'll do my work. What's payments going to do? Well, it's going to go talk to some payment gateway. And we like things to be asynchronous in event-driven architectures. And all the stuff on the bottom is asynchronous. Not everything in the world is, though, right? Because that payment gateway is probably synchronous, right? I make a REST call, and I sit around and I wait for that HTTP connection to work itself out and get a result back. So that'll happen. I'll get an answer back synchronously. And now I have settled that order. I'm confident I can get money. So I'm going to produce a new event to a new topic or a new log that says, hey, this thing has been paid for. This is a settled order now, which means we can ship it, right? And so the shipping service has work to do. That's nice. And it goes and it gets that object out of that log, or consumes a message from a topic if we use Kafka language. And it says, OK, great. I have this order to ship. And it says it's user number 24601, and that needs to be shipped to 24601. I don't know where she lives or what her actual name is. I can't ship anything to her. I need to go ask the user service. Now, there's this temptation, right, to make that a synchronous call at this point, because I'm kind of blocked on being able to do anything until I have that information, and we want to keep the users table in the user service within that context. So there's a temptation to do that synchronously, right? Well, I don't want to do that, so we're going to do this other neat thing. Here's a way that I can share data in a completely event-driven system. I do want a copy of the user data in the shipping service, which seems, I don't know, heterodox, a little bit maybe. But what we're going to do is anytime anybody creates or updates or deletes a user in the user service from that web front end, I will now produce an event to a change log. Now that change log, again, with Kafka glasses on, that's just another Kafka topic, okay? Or if it's some other, if it's Pulsar or whatever, it doesn't matter what it is, it's that thing, and we put that message in there, and it is the current version of that user. So when I create a user, produce a message to that log. Change my address, produce a new message to that log, which lets the shipping service now materialize its own little read-only key value store of users. So I can now effectively, in memory, look up user 24601. OK, that's this lady, that's her address, and I can create the shipment, and away we go. And I would most likely then, ideally, do this with another log. I'll produce an event, say, here is the order, and the warehouse can then go asynchronously pick that up and have somebody pick the products and put them in a box, and labels get created, and all those warehouse things happen asynchronously. Okay, so this is the reference architecture right here, and this is kind of what I mean when I say event-driven architecture. It more or less implies microservices these days, and this is the way we're going to be interacting. I want to look at 5 ways we can screw this up. That's your outline for the rest of the talk. We're going to have 5 of these things. 5 ways to go wrong here, but all of them are going to be with reference basically to this diagram. We're going to pick apart different parts of this diagram, which, like I said, I've been using this story in one form or another to talk about different concepts for a while, and it's, I think, kind of neat how rich this, completely fake, if you work in actual retail or e-commerce and everything, you may well be aware that you have more than 4 microservices in your whole system, right? But with just these few services in here, there's a lot to unpack. So let's do that. How can this go wrong? There are 5 ways. So The first way we can go wrong is when we use event-driven architecture and we just shouldn't have. Now, anybody who gives you an architectural paradigm and says, this is universally applicable, it is always the thing that you should do in all cases, is probably a person who is selling something, and even if they're selling something, they're not doing a very good job of it, right? You shouldn't sell things that way either. Not that selling is wrong, it's just that saying this idea works all the time is wrong. So there are times we shouldn't. We're going to look at a few of those, some suggestions of when this is the wrong approach. Sometimes people get a little excited. I was at a meetup last night, and I was talking about something sort of related to this, and actually using the same diagram for a different purpose, because I do it all the time. And somebody said, hey, isn't Kafka like a database? And that person was being a little bit of a troll. It was somebody I knew. He's right there. But sometimes when we start to internalize the ideas of event-driven architecture, we start to think, oh, hey, we just need logs of things. We don't need databases anymore. Databases aren't cool. This is the new thing that's going to cause me to not need relational databases anymore. That is an immature approach to event-driven architecture. So we're going to look at too much database aversion. That's a mistake we can make. Schema, this kind of sneaks up on you. This may or may not be obvious off the bat, but managing schema is very important. Just like databases don't go away, just because event logs become the center of our world rather than database tables being the center of our world, that doesn't mean that schema is somehow an obsolete concern. Schema is a first-class concern, and we'll talk about that. Writing in an event-driven system is usually fairly simple. Reading is usually not. Reading it might be better to give than to receive, but it's more expensive to consume than to produce. And sometimes people make the mistake of trying to build too much into the components that read from event logs. It's a very specific failure, but we want to look at what happens when your consumers are too custom. There are good things, and again, this actually kind of becomes a fairly Kafka-specific thing, but there are equivalents all over the place, however you're doing this. You need to make sure that you're not customizing those consumers too much. Finally, scale. We'll look at scale and not properly respecting how hard it's going to be. There are really two errors there. One is thinking, wow, we need to design this thing so we can be Netflix and scale that much. Well, I know it would be cool. You're probably not going to be Netflix, scale-wise. You probably don't need that much scale. But also just not thinking about scale and trivializing that set of concerns is a problem. So we'll talk about that. All right. Again, like I said before, anybody who presents to you an architectural paradigm and says, it's the paradigm that you use all the time, is a person who's not being trustworthy. This is definitely true of event-driven architecture. It's a great idea. I actually really believe that it's sort of a generation-long architecture paradigm shift that is going to affect the default way we build most systems for the next season of life in software development, 20, 30 years. I think it's a big and important thing, but it's not always the answer. And another painting that, I don't know, I've talked about this painting before. This is called The School of Athens. It's painted by an Italian guy named Raphael. And every single person in here is a person either from Renaissance Italy or classical antiquity. It's the guys in the middle right there that we tend to focus on. That's Plato, the older guy, on the left, and Aristotle, the younger guy, on the right. The guy kind of like, he's saying, you're here, you need to bring it to here. That guy, that's Aristotle. Very broadly speaking, when we are building things, when we're putting on the event-driven architecture hat, when you begin to think about a system, you don't begin by thinking about what is. You think about what happens. So going through the process of building an event-driven system, you think first about what happens. When you're building, just say, a monolith, you start with at least my thinking in a new application, maybe this is just me, but I tend to think of a schema first, right? And if I'm thinking of a schema first, I'm thinking about what is, not what happens. And then I work out what happens later on. Well, you have to have both of these, okay? And I'm going to come back to this idea a few times as we cover some of these other anti-patterns and pitfalls. You always have things and you always have events. It's just a matter of which one you're going to emphasize. Just like in actual philosophy, I mean, it's not obvious the degree to which Plato had a correct account of reality or Aristotle had a correct account of reality. There isn't a consensus on that. I mean, people disagree, right? And so whether you think events first or things first, you can prioritize one or the other, and that priority implies a choice of data infrastructure, which in turn implies an architectural style around that data infrastructure. But it's not like you always have to go things first or events first. And that's what this choice is really about. We're talking about the first mistake, which is using applying event-driven architecture when we ought not to. So when your scale is very small, when your system is very simple, you might not need event-driven architecture. If you're building something that's small initially, and it's just not very complex, you can really fit the whole thing into your head at once, and it's not designed for a great deal of scale, then use a database and write a monolith. Pick a framework that you like and build an application around that collection of state, and you're going to be fine, right? Don't overcomplicate this and deploy a Kafka cluster and I need Kubernetes because now instead of classes, I'm a little application that's got maybe 15 classes that interact. Those all need to be services, and I need to deploy those separately. Please don't do that, right? Terrible idea. Just build a monolith. It's fine. And I think a key point there is when we think of the word monolith, number one, it's bad, right? We just know it's like profanity. Monoliths are bad. We don't build. We're trying to get away from monoliths. Monoliths are big and imposing, and if you're one of these Australopithecines and you wake up and you see it there, it's like scary because it's a big giant alien thing. You know, if it's a small program, you don't call that program a monolith. Architecturally, it is one, and I think I want to give you permission to just embrace that. And if you're building something small, go ahead and do it. And if somehow you don't know the film, this is from 2001, A Space Odyssey. Strongly recommended. Outstanding film. The last 15 minutes, drugs are definitely involved. So just be prepared for that to be maybe a little confusing, but the rest of the film is great. You should see it. And again, I would say if something is small, if uncertainty is very high, like you don't exactly know what the business is asking you to do, and you're kind of spiking something and trying to sketch out an application, you're going down a path, you're not really sure where the path leads, then maybe events are not for you just yet. Just build something simple, architecturally simple, and try to learn what you're trying to do before you elaborate the architecture. And if it sounds like I'm giving guidelines for when or when not to use microservices, to some degree I am, right? These are not equivalent questions, but they're very related questions. And in my opinion, the guidelines and the reasons not to use events sound like the reasons not to use microservices. All right. I didn't show you in that reference architecture. I showed you the asynchronous version. Now, it's possible to build a system that looks like that, not use events, not use event logs, and have those services all be synchronously coupled, right? So I still have microservices, but they're calling each other with REST or something like that. That's not what I mean here. That's not a good substitute for event-driven architecture. So you might say, well, I'll still build services and I'll just have them call each other synchronously. If I could just make the claim and for now not defend the claim, maybe find me later tonight at the reception and you can try to get me to defend the claim then, I'll say, don't do that. That's not what I mean. Sometimes a monolith is the right thing to do, and just do it. All right, number two, how to go wrong with event-driven architecture when you should have used more databases. Now, there are centralized databases in the world, and their presence is not somehow a failure. It's not bad. It's nothing to be embarrassed about. It's just kind of how things are. And so your life, as you're building your new event-driven system, it's probably going to coexist with legacy systems that involve databases. Maybe it's a big, giant, scary mainframe. Maybe it's just a nice little Postgres database that's doing something useful and making people happy. An observation is that old paradigms, and I'm kind of proposing the data at rest, database-centric application architecture, I am saying that is the received paradigm. That's like what has been happening. We could say that's the old way of doing it. That's a little bit judgy, I think, but we'll just call it that's the thing that we've been doing. We're going to keep doing that, and we're going to build new systems that supplement those old systems, that don't replace them. That's how it works. A little bit before I really got into software, or this kind of software, early in my career, early in the 90s, I was writing firmware, so I spent like 6 or 7 years completely ignorant of what a database even was. I got to debug software with an oscilloscope. That was pretty rad, but I just didn't do any of this stuff. But early, as a younger man, the relational databases, what we called open systems and all that kind of stuff, those were pushing mainframes out of the way as the right way to build a new system. But they didn't make mainframes go away. They're still here, right? You just built the new thing on the relational database. And now we're building the new thing with events and leaving the old systems in place. That's fine. So there's a whole set of tools called change data capture that help this coexistence work well. And I'll give you a link later on. In fact, twice I'm going to give you a link in this presentation to a website that's got more things to just dive deeper if you want to know more about change data capture. There's all kinds of talks we have online for that. But that's a good way to sort of extract data from a database and put it into an event log. I just want to say it's okay if you have databases doing important work. You need to keep that in mind. I'm belaboring this point because you don't want your new affection for events to convince you that you just don't need databases anymore. It's not true. Or, well, I saw this talk online that Tim gave a few years ago where he was talking about how you can get ACID transactional properties out of a system with Kafka, so I guess Kafka's a database, I don't need databases anymore. Like, just don't say that. Or if you say that, don't say I told you to say it, because I told you not to say that. Another, I think, sort of mature thing here is to think about skills, right? Maybe I still want to build a database-centric application or use that sort of static data at rest paradigm because events are hard, and this is actually a difficult way to think. I didn't take a class in this. Nobody's built one of these before. It's actually hard to think about how to solve problems asynchronously if you've been doing synchronous data at rest stuff for your whole career. So you might not have the skills as this skilled balance. I don't know if you've ever really thought about somebody trying to work on a balance beam. I have a daughter, she just turned 25 2 days ago. 25? Let's go with 25. 2 days ago. She was a gymnast all through her adolescence and teen years, and if you actually watch a child do things on a balance beam, it's terrifying because it looks really dangerous. There's a lot of skills involved there. And I think the point of the slide is you might not have those skills. And so you might say, hey, let's not go there right now until we can get those skills. And I think that's a mature judgment sometimes. When there's a new paradigm that's beckoning and you've got this high-risk, high-visibility project, you could use it or not, and you think, maybe not yet, maybe it's not time. Now, that will trap you over time. You can't live there forever, and so, ooh, shameless plug for Confluent Developer. This is a site that is very near and dear to our hearts, where I work, and it's got a lot of great content, video courses and library of patterns, and I can plug it because it's free, and in fact, you can't even register. So you will not be turned into a marketing lead if you use this website. We have no idea who you are. You just go there and get stuff, and hopefully you're happy. Okay, another problem. Remember, we're focusing right now on when you should have used more databases. What's another way you can go wrong here? Well, let's look back at this system here and that table over there in the user service, okay? Now, straightforward enough, this is where my users live, and it's like a database table, and it's not that hard. some Kafka-specific details, because that's just where my head is. There's a stream processing API in Kafka called Kafka Streams, and it will let me basically maintain a table. Basically, it's called a K table that acts like a key value store. Right? I get one key, and I can use that to look things up in memory, and that's backed by that changelog. Do I have? Yeah, I do. Okay, that guy down there, that topic, that changelog topic. I can effectively materialize that in memory as that table and as that table and query that in memory, and the framework does all that stuff for me, right? So I could say, hey, I've got events, I've got Kafka Streams. Dang it, I learned how to use Kafka Streams. It's not easy, but I watched that video on Confluent Developer that Tim told us about, and I have superpowers, and I'm going to do it, and I don't need a database anymore because I'll just make it a K table. Well, maybe. Okay, that's good. There's good reasons to do that, but it also might be bad, because remember, Kafka Streams, a K table, is a key value store. I can look up by user ID. That's great. All right, so I've got that. But what if I also need to look up by username? Or I forgot my password and I need to look up by email or something like, if I've got multiple keys, dang it, just make it a database. It's okay. So don't be allergic to databases just because we're using events. The thing that changes when we adopt event-driven architecture is that the system of record, the place data goes to be known and stored and remembered, is an event log. Databases are views of the events in that event log. They are necessary views, but they are not once you've really asked event-driven architecture into your heart, this is kind of what you're doing, those databases are things that we materialize from the system of record. They are not things that disappear. So you'll always have databases as a part of your life. Number 3, our third way to screw up with event-driven architecture is thinking that schema doesn't matter. Schema does matter. Let's look at that guy down there, that topic. So I have orders. I get them from the outside world, and I validate them, and then I write them to this event log. And why do I write them to the event log? Well, because in my minimum viable product, the payment service needs to know what to do. And so my thinking as the developer of the order service is I put this event here because either I'm going to go write the payment service or my friend over there is going to write the payment service, and they need something to do. So as I'm thinking about my minimum viable system, I'm thinking about the producer and the consumer. That's in my mind. And that's fine, okay? What else might happen, though? Maybe down the line, a future version of me, or down the line, somebody else. Maybe it's somebody I work near. Maybe I work for a big company, and it's somebody I don't even know wants to do some new things. Like maybe they want to do fraud detection. Okay, now maybe fraud detection has to live in between orders and payments, and so we'd have to change things. I don't know. Maybe this is like asynchronous fraud detection, and just there's a dashboard that somebody has that says something might be fraudulent. But I can write that service. Somebody can write that service because the orders are in the log. They are knowable. Maybe I have a customer loyalty program, so I can send annoying text messages to people that say, hey, thank you for being one of our platinum customers, and I don't know what we sell. It's toilet brushes or something, and you spent more on toilet brushes than anybody else, and so you're a member of our Shining Porcelain Club or something. That just came to my mind. It's one of those things, you go there and then you wish that you had thought of a better example, but it happened. And it's on YouTube now. We just have to live with it. So, as I said, the pivot that happens isn't that we expunge databases from our lives, but the event log becomes the system of record. This gives us the opportunity for a relatively more evolutionary architecture than we probably would have otherwise realized, right? We want something that's more like an ecosystem, where there are all kinds of plants and animals in there, and no one person needs to be on top of all of that. No one developer. You know what you're working on, and it serves business goals, and it's governed by some kind of process, and people know what you're doing and how to deploy it and all that stuff. And there are other people who do other things. But you don't need to fit that whole ecosystem into your head. Actual living systems like this, I think, are much more flexible with respect to schema, right? There's a few primitive types, if you think about it. There's like water and oxygen, carbon dioxide, and some amino acids, and like some lipids, and you get into glucose and its friends and polymers of it, and that's like it, right? And then things eat things, and not everything can eat everything else, but there's surprising amount of flexibility in what can eat what. And that kind of works out without too much schema. We're a lot worse at schema, so we have to be a little more systematic. And to get specific, a way to do this, again, kind of with my... I didn't explain the shirt, by the way. I should explain the shirt. I always forget if I don't explain it up front, so I'm just going to stop right now, because I was about to talk about Kafka again. But this Kafka shirt, it's fire, the wheel, and Kafka. Those are like the three fundamental innovations of mankind. It's super funny. If you're watching the video later on, I want you to know that there was a murmur of a little bit of amusement that happened there. I don't know if that came through in the recording. I won't say it was laughter, but it was like mild amusement. All right, so a fully managed Kafka kind of lens on this. This is a topic in a Confluent Cloud cluster that contains orders, and they are protobuf orders, and here is the schema of those orders. There's a component called schema registry, and this is in this cloud product. You can also just use it for free and manage your own. But we have to track this for two reasons. Number one, I have to be able somehow to look at that topic and know what's in it. If I want to write a service that consumes the data there, I have to have some kind of automated mechanism to build, POJOs from this that will let me, write code against the current version of the schema. I also need to be able to manage change in the schema over time because, well, the schema is going to change, right? Because that's what schemas do. Even if they're perfectly correct at one point in time, the world changes, and so our schemas have to change. And so that's the thing. And this is a hint. Remember the Aristotle, Plato? You had Plato pointing up, you had Aristotle like, bro, no, down here. That whole thing. This is that tension working itself out, all right? Because I have to apologize for the gross generalization here, but the sort of Aristotelian events first thing, that's just terrible. I can't even call that Aristotelian. It's more of, it would be more like William of Ockham, maybe, but that's a different talk. But this events first thing, where you're thinking about what happens, not what is, well, it's like the things insteed of events. Here, things are popping their head up out of the stream of events and winking at you. They're still there. You still have to deal with both of these things. You can think of things first, you can give things priority and choose data infrastructure that prioritizes things, and that's a database. Or you can think of events first and give events priority and choose data infrastructure that prioritizes events, and that is Kafka or something like it, some sort of event streaming system. Those are two different approaches to data infrastructure, two different approaches to prioritizing the tension between things and events. But in both cases, if you go events first, you still have to know their structure. That's a thing. If you go things first, well, the things change. Those are events, and you have to process those. So in both cases, they're always there. It just depends which comes first. Now, this gets into something I think is interesting, and this is data mesh is a new idea, but this could totally be selection bias on my part, but I'm seeing it talked about a lot. So I just want to take a brief little excursus over into data mesh territory for a minute. And think about this, because it's a way of, I think, helping us navigate this tension. more from an analytic standpoint than an operational standpoint. I've been talking about application architecture, but this brings this over into the analytics world. So there are these 4 key principles of data mesh. Number 1 is that data is owned by a domain. So like we are the people who build the orders service, and so we're responsible for publishing and maintaining and thinking about the orders data from an analytics perspective. So anybody in the organization wants to do analytics on orders, well, we're the team who writes that, so this is our data. We own it completely. We understand it. And we think about it like a product. It's not just, oh, well, yeah, there are rows in a database, and data warehouse team, you can read that table. That's not very nice, right? Like, take it if you want it. That's not product thinking. Product thinking would be more like, no, wait, this actually matters. We're going to document this, and there will be a schema, and we're going to carefully publish it and manage the quality of it, and all that happens. You know, it's a new thing application developers get to do, is manage that analytics output. That data is available everywhere, subject to governance concerns. It's a thing that I publish. So again, with Kafka lenses on, if there's a topic, I can produce my analytics events to that topic, and anybody who's able to read that topic now can consume that. And data governance is we won't get into that. It's a data mesh thing. There's this principle of federated data governance, which is a good idea. But this is, when I think about schema in an event-driven system, my mind goes here. Maybe a year from now it won't. Maybe a year from now this will be 15 slides in this presentation because it'll be a much bigger idea. If you want to know more, the idea, certainly not mine, it's the brainchild of a lady named Jamek Teghani. Jamek gave a keynote at the Kafka Summit Europe in, boy, I want to say April? I don't know, this year is kind of fuzzing out a little bit, but you should definitely take a picture of that QR code and check out that keynote. It's great, and I also had the pleasure of interviewing her on my podcast, the Confluent streaming audio podcast. So just Google Jamek and go there, you'll get the correct spelling of her name, and Google her and check out data mesh if it sounds interesting. So schema is pivotal to this effort. We have to understand what the stuff is in there so that things can emerge, so that other services can emerge around there, and there you go. Don't disrespect schema. Okay, the 4th way to mess up with event-driven architecture. Before the pandemic, I was toying with the idea of getting some tailored shirts made, and I think people have been dressing down a little bit in the last year and a half, and so that just hasn't seemed like a big priority. And you can get it done somewhat affordably where I live. It's like not the worst idea. I had to kind of wrestle with myself, right? Like, do I want to be the kind of person who gets tailored shirts? Like, then I have shirts that fit better, but I also get tailored shirts. There are no solutions. There are only trade-offs. But like, that's fine. Maybe, again, if we talk later on at the reception, you can help me work out that little identity crisis of my own. When it comes to the programs that read data out of event logs, they're always custom, but you don't want them to be too custom. So let's talk about that. Just for Kafka context, a quick reminder of how this works. I've got a topic, that's my event log, it's broken up into partitions, and I have a program called the consumer. That consumer can just be like a single instance that reads all of those partitions. Because this is a log and not a queue, I can have more than one of them reading from the same topic, and that's fine. You can have as many as you want. That's kind of what I was saying in the schema section just previously. I can also scale these out, right? I can add instances of any of those consumers, and the partitions will just get automatically reassigned to those extra instances. So I can scale compute, and that's pretty cool. That's essentially free with just completely vanilla Kafka. You have code that looks something like this. This is horizontally, elastically scalable consume code, but in the middle there's not much going on. That API, potentially dangerous, you just get an object. It's got a key and a value. So, you know, if this is all you know, and you go off and running, and you start writing your services, and you're like, Tim really convinced me that event-driven architecture is a good idea. I'm totally going to do this for the rest of my life. That's great. And this is all you do. You're going to do things in there, and you're going to compute aggregates, which means you're going to have to group over a time window and run some reducing function over the group. You're going to enrich one kind of an event with another kind of an event, which is you have to do like a join, and that's hard to do. Okay, there's a lot of stuff that's going to happen there, and you're going to be tempted. That's supposed to be black. Don't worry. Don't panic. I've learned that black slides can be very unsettling, and I don't want you to be unsettled. It's supposed to be black right now. So you're gonna want to build a lot of framework to get all that stuff done, and you know how it is. You write it once, twice, like third time you write it, you're like, oh, I'm gonna build a framework. This is a good idea. Well, that's a trap because that's not your job, right? Your job is to deliver features that benefit somebody in the business or your end customer or whatever. So Admiral Akbar, famous software architect, is warning you against that trap. You don't want to do that. So like if we think about this, I've talked about this, and I'm really not, I'm talking about particular ecosystem things like Kafka streams, K-tables. I know I haven't spent time introducing that idea. So some of you are Kafka streams developers, you're right there with me. Others of you are just kind of going on the little bit I've given you. But the little bit I gave you was that changelog down there, that's got a new message in it for every time anybody has updated a user object. Well, I need to now pull that into some in-memory thing, like a hash table. Let's just say it's a hash map. It's a Java hash map, right? I can turn that into a table, no problem. It's a hash map, easy. Well, oops, went the wrong way. Hi, Admiral, miss you. That's not so easy, because what if it looks like this, right? What if I have two instances of that consumer, and some of the hash map is here, and some of the hash map is here? Well, that top instance, look at the lines. It has users that are in partition 0 and users that are in partition 2. And what if I have to scale that out? Because I said, well, gee, I have all this horizontal scalability. It's so cool. Let's do that. We'll scale it out, and now the users that were in partition 2 have to come out of that hash map in consumer A and go into this completely new JVM in its own image somewhere else in the Kubernetes cluster. And you don't want to do that. Like, you're not in that line of work. That's the trap, right? You don't want to start doing distributed state management. So this is what I mean by going to the tailor for your consumers. Your consumers contain business logic that's unique to you, that serves your customers, that serves your business, and that's your job, is to deliver valuable features to the people who rely on your software. There are all kinds of infrastructure temptations which you must avoid, fun as they might be to solve, and state management is chief among them. Also, I mentioned grouping over time windows. That's super hard. Managing time in an event streaming system, that's almost certainly not what you get paid to do. So don't do that kind of stuff. There are tools, in the Kafka sense of things. I've got the Kafka shirt on, so this is totally fine. Kafka Connect, Kafka Streams, KSQL DB, these are things that you'd use to get that kind of work done, rather than build any of that functionality yourself. And this is all, again, there are great free video courses and talks and blog posts and executable tutorials and all kinds of stuff you can go do to learn more about those. That's not our goal today, but it's important to know this is the way you can go wrong, since reading from topics is kind of what you do. You want to make sure that if somebody else has solved a key infrastructure concern in that consume part of the life cycle, that you go to the source and do that. All right. Finally, number 5. If you think scaling is going to be trivial, now again, sometimes we over-rotate on scale because bigger is more awesome, and we think We need to make sure we can scale everything to the nth, because wouldn't it be cool? And that might force you to over-design things. See our first anti-pattern when you shouldn't even use event-driven architecture to begin with. But if you are, you want to respect scaling. You want to make things such that they will be able to scale, and it's hard to do. You have to ask questions, as I said a minute ago, like, how much are you really going to do? Make sure that it's going to be some. Does it need to be elastic, or how elastic does it need to be? Do you have very spiky loads, like retail? At the beginning of the cloud era, when S3 and then EC2 were launched, like 2005, 2006, the mythology that emerged right away was, oh, if you're an online retailer with EC2 at Christmas time, you can just spin up all these extra instances and pay for that compute, and then in January you take them down and you don't pay for that compute anymore. I don't know if you were building applications in 2006, and if you were, if they had anything like that kind of elastic scaling capability, like 99% chance they didn't. Nobody was building applications that did that then. That's actually really hard to do. But you do have to think, am I going to need to scale? If so, do I need to do this up and down kind of thing? You have to ask those questions. Will you scale storage? Will you scale compute? Those are two separate things, and you have to think about whether they'll scale. So, scaling compute. Looking at this diagram again, you need to understand how this is going to work. Now, scaling on that consume side is rough. We just looked at the state management problem, and we said, don't assume responsibility for that. But even if you do, you're doing this in Kafka, and Tim said Kafka Streams was good because it handled scaling of state for you. Great. Well, you still have this Kafka Streams application that you still have to be able to scale. So you're going to have, Kubernetes or something, if that's not already a part of your life, you're going to have to think about how to manage that. To do that scaling. There's also, in the Kafka world, this language called KSQLDB that insulates you from a lot of that scaling problem. Now I've just got this one cluster of KSQLDB servers, and I throw these queries at them, and they do my stream processing for me, and I scale that one cluster rather than bringing that into my application code. So I keep my applications simpler and maybe just use that simplistic consumer API and have all my interesting stream processing done in SQL. That's kind of a nice thing, because scaling that looks like this. How many nodes do I want in the cluster? And there's a nice web UI for that. Oh, I'll take 12 today. Okay, there you go. Now, when it comes to scaling storage, you have two choices. You can make a bigger cluster, or you can tier your storage. All right. Now, bigger is the approach taken, say, by the Sequoia tree. It's a kind of tree that lives in California. They're massive, right? And that's successful. Sequoias are super successful, but expensive. Sometimes that's what you want to do to scale storage, but sometimes it's not. We can also take a hint from the way we scale storage in computers, right? So here is a picture of the Z80, and the expanded version on the right there is the register file of the Z80. This is from Ken Schrift's blog. It's Righto.com, RIGHTO.com. So amazing. Check it out. It's just pure fun. But anyway, he's got this picture of this guy. We've got the register file, right? And then there's RAM. There's a couple levels of cache, and there's RAM. And then there's a disk. And if it's an old-fashioned disk, it looks like this, right? So we have these tiers of storage in memory inside computers of very high cost, very fast, very low cost, relatively slow. And in event-driven architectures, pretty much you're seeing that same thing emerge, right? Like I showed a screenshot from Confluent Cloud. If you use Confluent Cloud, you have tiered storage. You can put old stuff in S3 if you want, or Azure Blob Storage, or whatever it is. If open source Kafka has a thing called KIP 405, it's doing the same thing. All right, let's wrap up. Instead of thinking about how it can go wrong, let's think about how we can get it right. Number one, we'll use event-driven architecture only when we should. Number two, we will embrace databases appropriately. Embraces should always be appropriate. Hugs are life, but there are rules. And so we want to use databases, not be afraid of databases at all. Manage schemas. You want to think about schema. Just because we're building systems based on what happens doesn't mean what is no longer a question. So manage schemas. You want to use appropriate compute frameworks in your consumers. Don't do it all. There's KSQL, there's Kafka streams. If you're in the Kafka world, those are important things. And use managed services when you can. You don't want to take on the burden of operating complex and sometimes persnickety distributed systems. You have to ask me later what persnickety means. That's a very idiomatic American word. We can talk about that later. You don't want to maintain a persnickety distributed system if you don't have to. So we looked at how things can go wrong. This is how it can go right. And I want to say thanks for being here and have a great conference.